All right, let's get started here. So, my name's Scott Champagne, and we are doing Unit 13 of the Linux Systems Administration course. This is, I'm recording it a week late. We actually did do the meeting last week, but I'm going to get us going and talking about the topics for this week. So, if anybody's been following along, we have this down in the Discord, so if anybody wants to do the course with us, you can. You just have to go spend time down in there. All right. So here's our announcements. If you have questions, ask me down in the Discord. This is our 13th class meeting. We don't have any reschedules this week. We don't have any of that kind of stuff going on. But if we did, they would go here. I would let you guys know about them or whatever. All right. So let's talk about what we did last week. So it's good to review the week before. We talked about capacity management, capacity planning for architecture, storage system testing. We were doing monitoring of systems, and then we were looking at the different ways that we could analyze data, right? If we were looking at past data to look at capacity, if we were looking at past data to look at discrete incidents that had happened, if we were looking at future forecasting or prescriptive, being able to cause things to happen, that was the kind of stuff that we were doing in our discussions, right? So the discussions are all up in the Discord if anybody wants to do those. But then we talked about, taking notes and review the material. We're going to do that each week. Labs, we're going to have a lab each week. You guys know that. And then we've got a project. If you're doing the project with us, we're in week 13 of 16, so it's getting pretty far along. You guys want to be working on those, and we have some study groups and stuff for people to keep working on that. All right, this week we're talking about security hardening of systems, right? This is an important concept. I think that it's one of those things where I'm going to show you here in a minute, but there's no engineering to what I'm going to show you. Well, it's engineering in that we can design things and build things, but there's more of an art to it in that I can't give you an exact equation of this system is secure. There's going to be a continuum, and we're going to be on one side of it or another on different things, and we have to find that balance within our organization. So we'll talk about that. Our discussion post, one of them is a security team discrepancy. There's a problem in some of our prod servers, and how did it get there? How is there a discrepancy between the configurations, and how are we going to fix it? And then we're talking about building a new hardened image, and we're going to talk about those things and stuff. But in the discussion, I ask you, what would you go look at, and what would you go figure out about what's already in your environment to see maybe some clues about the security posture of your organization? Do you know what types of security standards you have to adhere to? Because if there is no standard, it's the wild, wild west. You do whatever the F you want. But if there is a standard, and if there have been risk assessments, then we do have to be to a certain type of security posture. So that's building a new hardened image. There's a worksheet for this week. We'll get into that. There's a lab for this week. We'll get into that. And then there's the project. You should be finishing up the project if you're in week 13. So, all right. Let's go talk about the topics for this week. We're going to harden systems. We're going to talk about the purpose of hardening, what it is, how it exists. We're going to talk about when and how we harden the systems. On the initial deployment of a server, there should be a certain baseline that it's going to hit. We're going to do that typically with like a pipeline, and then automation is going to be built in, and we're going to talk about that in the next week, which I'll record later today. But in the initial deployment of things, we need to get to a certain security level, right? There needs to be a certain focus of security, and we'll talk about that. And then also we in operations, we use a tool like change management and this process where the servers stay the same. We want to minimize server drift off of our baseline because servers will drift. And you say, well, how? Well, because people have admin in the environment. You're typically not dealing with immutable servers. We do want to get to immutable servers eventually. It's just we're not typically in an organization at that level of maturity just yet. Some organizations may be approaching that, but I haven't seen that yet anywhere, and I've seen some pretty big ones. So, anyway, so let's talk about this. So, the purpose of hardening systems, right? We harden a system to a security standard as we deploy them, and then we can use our own standard if we want. If we just have a standard like, hey, needs to at least have a long password. I don't know. Well, a long password doesn't really say much. The standards will be, a certain number of characters, a certain number of non-repeating characters, a certain number of classes of characters, upper and lower case, special numbers, right? which makes a total of 72 total base characters, and then that makes bigger and bigger, more what we would call resistant to entropy and decay on our passwords, right? But then we find, properly aligns to the security posture of our company's acceptable risk profile of systems, right? So we're trying to secure our systems, right? All right, so here's the security dichotomy. I often talk about this, but I thought that this was a good way to talk about this old saying. There's an old saying in systems world: security is the enemy of productivity. Now, that's not to say that security is bad. Nobody said security is bad, but there's a dichotomy here. You can have perfect accessibility to systems, which is anyone can view, anyone can change, anyone can use all the resources. That is a perfectly accessible system. Any user can come in, they can just lay out and take all the space. They can view anything and they can change anything. But perfect security adheres to the confidentiality, integrity, and availability triad, which is exactly what I'm using here to say we protect the view. Only certain people's eyes can slide across certain pieces of data. Only certain people or processes can make changes. That's the integrity of data, right? And also we protect the data against the slow decay of time. And then the desire of all things to go back to even, right? That's one of the rules of what's that? All energy goes to equal in an environment. What's that called? Somebody here knows. That's one of the laws of thermodynamics, right? And then the last one is protected availability. We need the system to remain available. Therefore, we limit how much a user can take of the system so that there's resources for others, right? So protected view, protected changes, and protected availability are the confidentiality, integrity, and availability of a system versus perfect accessibility. And we have to have a security posture that adheres to this. So, for example, I put port 22 open with SSHD on a server, right? So you can SSH in. And over here, I allow any username and password, whether they've ever been programmed into the system. Anybody can come in. Most of you would immediately go, well, that's silly. That's silliness. Like somebody can just come in as SpongeBob with the password SquarePants and get in your system. And I say, yeah, that's perfect accessibility. And you go, hold on, that's a little weird. Let's at least put a password. And I go, okay, so you moved over here a little bit. And then I go, okay, well, username, but somebody goes, well, passwords are inherently insecure, so we actually want to use only RSA style keys. And I say, not DSA? And you say, no, DSA is old. And I go, okay, so you're not over here, you're over here. You want RSA style keys. RSA style keys are a little more, they have a little more entropy to them. They have a longer number of characters, right? So we move just a little over to the right. And then you say, well, you know, that's secure and all, but I'm also going to lock it down by the number of IP, by the IP range. And I go, oh, wow, you're moving over here a little bit more, because now people can't even access the resources unless they're already in your IP range, right? So where I'm going with this is this sounds like it's some abstract platitude, like I'm up here, you know, sitting on top of a mountain just spouting off stuff that doesn't really matter. But there's a practical aspect to this, what I'm showing you guys right here. And we're going to kind of get into that a little bit. All right, so how do we harden, right? We use standards. We can either use our own standards or we can get them from somewhere. There's standards that are out there. There's the STIG standards, the Secure Technical Implementation Guides. They're called STIGs. There's the Center for Internet Security, CIS benchmarks. There's PCI DSS standards, which are your credit card standards. There's 12 different things that you have to adhere to in a PCI DSS environment. I think they're up to PCI DSS version 4 now, as of a couple years ago. And then with that, you have to self-attest every year to being at that standard, and you have to have a third party come in. So there's 2 verifications per year for some of those. Then there's tools. There's OpenSCAP Workbench. There's this SCC tool for scanning, and I'm going to show you guys how to use those a little bit, and we're also going to talk about them in the labs and that kind of stuff. So how do we harden systems? We find a standard. We use our tools to adhere to it. We can do it manually, but it's just there's so much work. I wouldn't advise doing it manually. So hardening best practices. What do we actually do on like a Linux box, right? You can get security standards. They're going to come from your governance, risk, and compliance team. That's your GRC team. That team tends to be over on security. They're not part of operations. They're going to be coming down from security and saying, hey, you have to build things to a standard. You have to do this, whatever you're working on. So all your passwords needs to be changed. You can't use default You can't have admin. You can't have Ubuntu and whatever, unless you say, well, Scott, that's just not tenable for us. Well, I go, well, then make sure that you know how dangerous that is, because you look at my home lab here. This is just the last 6 hours of people trying to get into my systems. Some of you guys have seen this before, but I want to show you that Ubuntu and MySQL, I guarantee you they use the default passwords to see if they could get in. Sysadmin, Ubuntu, sysadmin. There's some other generic ones that are, those are just bullshit passwords. Root should never be root or tor or empty or admin or any of those kind of things. You need to go put a password on it. Or even better, disable root access through SSH, right? But now you move just a little over to the right on that security continuum we were talking about, right? Postgres, somebody wanted the default Postgres. Somebody, whatever default user might have been. Git, admin, GitLab. So they're looking for default passwords for systems to get in. Oracle, Confluence, Marty. Marty's a common one. I don't know if Marty's a person or a thing. Moodle, they probably use admin, right? Guest. So ES is a big one because that's Elasticsearch. Elasticsearch always comes with an ES user. You either need to disable that user or change the password for it, right? And then Telnet, who in their right mind? But anyways, I show that to show you that you need to change your passwords, right? That's just a thing. All default accounts either disabled or removed if not used, right? So all default accounts, so if somebody has Elasticsearch but you're not going to be using it, or Prometheus and you're not going to be using it, you need to remove it. You need to benchmark, or this really would be better to call this baselining. CIS, STIGs, OpenSCAP. There's a bunch of different standards. So these are two standards, and this is actually a tool that will help you to get to the right standards. So that's fine. Software. If you're going to run software on your Linux systems, which I know you are, you need to update it or patch it. There's common CVSSs that are coming out. That's the what are they? They're the vulnerability. Common vulnerability security score, something like that. You can look it up if you want. It's a NIST standard. But there are constantly vulnerabilities coming out. I forget what it is, but you need to have software only on your box if it's needed. There's no reason to have cups on 99% of Linux boxes. I was surprised the other day when a 10 security score came out as a vulnerability because the CVSS scores are rated from 1 to 10. And I was surprised when a 10 came out and all these people were scrambling to fix cups. And I'm like, in hundreds of thousands of Linux machines, I've never seen cups run, ever. But people were telling me they do. And I say, okay, well, that's fine. Okay, you need cups on your print machines, I guess, because it's a printing service, right? So why is it on all your web servers? Why is it on all your other, that doesn't make any sense. It didn't make any sense that this would be on anywhere. So your software, you need to run your systems as lean as possible. Why would you have things running that don't need to be there? That would be like if somebody came up and they had a drag racer, but then that drag racer had like a towing thing off the back of it. And I'm like, you're going to run a faster quarter if you take whatever it is off the back of it. And they're like, yeah, but that's fine. It can just be there. And I'm like, yeah, not when we're dealing with the types of speed that we want to get out of certain systems, right? So anyways, that's also a security concept because it's less of what we call a footprint of an attack to our system, and only running if needed. Now, when you look at a Linux box, right, just some system here, I've told you guys this before. The only way somebody can connect to this server here is on one of these ports that are open. What's going on here, system? This is the only way that somebody can connect is on one of these open ports. If a port's not open, it can't be connected to. This isn't like some hacker movie where they're like, I'm in because I opened a port. No, like the port has to be open, or there's nothing to accept it. There's TCP ports and UDP ports numbering between 0 and 65.534. 65.535 can't be used, right? But those are all the ports, all the TCP and all the UDP ports, right? If you ever need a list of them that are known on your system, it's Etsy services. Now, those are the named ports, but by the way, you can open any port. Just because 19922 or 19221 isn't named in here doesn't mean I can't open that port. We can open that with netstat right now, anytime, or netcat. Netcat can open and listen to ports on your system all day if you want it to, right? But the point is, the reason I bring this up is this is lowering your footprint. Then you should have host intrusion detection systems, so good logging systems. Loki or syslog are sending logs off in real time. So host intrusion detection is the fact anybody's doing anything on your system that they shouldn't. They're trying to rattle doors or hit your SSH, whatever. That's going into varlog secure, and then that's going off your system in real time, right? That's part of your security. Host intrusion prevention systems. So host intrusion detection, watch, and alert. Host intrusion prevention actually make changes. So Tripwire and Fail2Ban can make changes based on what's happening within your system. Tripwire hasn't been updated in a long time. I think we were looking at it the other day. I don't think it's been updated in many years. But there are probably forks of things that could be useful that are like Tripwire. They're just watching for files to change in your environment. Your host level firewall should be on. And this is because even if somebody makes a mistake and turns on software that shouldn't be on, the host level firewall will still block people from being able to connect to it. So that's another layer of what we call a defense in depth style of security, right? And then something that's maybe secure, like, and again, this is all going to go back to where are you at here. But me, I don't allow root to log into my systems. You have to come in as a normal user, and then that user can come up to root. So I'm moving more towards security because root can't log directly into my systems. I don't allow that in my environment. All right. So you can set that inside of etc sshd_config, or there's the .d directories, which are extensions of each of your different directories, right? All right. So when do we harden, right? We harden as part of like a deployment. So as a security baseline, we put it into our build pipeline. So we use Ansible and other tools to build in these hardening things as we go. We have to build partitions into a system as we build. It's very hard to add partitions to a system later. It's not impossible. It's just a hassle. And with thousands of machines, you would rather just build it into the pipeline so it's automated coming out. And then you need to do software and updates on your initial system. So like your golden image system, you want to build that stuff. And then with change management while running, what's going to happen is there's going to have people in this area here. You've locked your system down over to here. Perfect security. You're going more towards security. And then the users are going to come. The developers are going to say, hey, well, we're writing this application, and this application is an API, and it's going to be open on port 5000. Can we allow port 5000 in our dev environment so that we can test? And you say, yeah, I'll allow port 5000. That's sliding away from security towards accessibility for their application. But hold on. With the knowledge that when it goes to production, what they're probably going to be building as a container or whatever is going to be fed into a Kubernetes system, and the Kubernetes system is going to balance this. Because just because your container and then later on your pod, just because that accesses or exposes port 5000 from your app does not mean that's what's going to be actually exposed inside of your infrastructure, right? Most of you guys know that if you spend any time with Kubernetes. But the point is, while they're developing, I have to push over a little bit to give them access. Otherwise, if I stay over here on perfect security and I'm just rigid like Javert, does it get his name right? Yeah. If I'm rigid like Javert and I can't do anything but see the law, then you're never going to be able to develop your apps, and our company's just not going to get anything done, right? So there has to be kind of a balance with some of this stuff. And what's going to happen is while systems are running, people are going to make changes. So we need to have changes with authorization. We can't just let people do changes all the time in our system. And then and changes that happen outside of change management are a common occurrence. We don't want it to happen, but we call that configuration drift. When the configurations start to drift between like a dev environment and a test and a QA and a prod environment, we don't want that. We don't want that drift to happen. And then we need to keep our systems updated with patching cycles and testing by testing in lower environments and doing our patching and then moving up through until we get to production. because the things that are customer facing, we need them to be secure, not vulnerable in different ways, but also they need to be available to our users. So this is a dance that's always happening. Okay. All right. So who enforces the standards, right? There's typically security teams. Your GRC team is going to come around and they're going to be constantly nagging you to keep your security standards up. You also, as systems administrators, this course is on system administration, you constantly have to think about the security of your systems. You are responsible for the availability of your systems, which is one of the three aspects of confidentiality, integrity, and availability. We care about availability, but confidentiality and integrity are a big part of it as well. So security teams, they're going to have scanning tools in your environment. They're going to be constantly kind of auditing you and yelling at you. They're going to produce reports typically that deal with the risk and compliance of the systems. And then you need to have an accounting for any change that happens. So if a change happens in your environment that they catch, you need to be able to say, hey, that goes back to, this change record with the change management team. Because here's the thing, and I tell my engineers this all the time, I tell my admins this too, but especially my engineers, I know a bunch of people who they get super stressed about this kind of stuff. Like there's a change and there's a security vulnerability and this and this and this, and their stress level goes way up here. And this is what I tell all my junior engineers and admins. You don't need to stress one bit once you recommend it to management. Once you document the problem and you say, here's the proposed solution and here's what we're ready to test and go into whatever, you don't need to stress anymore. It's on them now. Now you say, well, yeah, but I'm going to have all this extra work. Yeah, but I don't need the stress of the decision. The decision's on management. The decision's on somebody else. I just need to be ready to do the work, if that makes sense. So I know a lot of people who stress over this kind of stuff, and it's like, no. We'll do our part, and then we'll let them go do their part, right? Systems administrators, you're going to have tickets constantly coming in to ask you to punch holes in security. They're going to be like, hey, I need this application, I need this software, I need this, I need that. That's fine, but is there a valid reason? Make sure you document it as part of a change record, and you go through your change thing. And then, if it's really something that's necessary, like let's just say there's some application that's really needed. Some library for, here's a common one is Boto 3. Does anybody here know what BOTO 3 does? Boto 3, it's a Python library that does something very specific. It's an API into something. Does everybody here know what Boto 3 is, or anybody here use it? You can Google it if you want. Boto 3 is almost always needed for your developers. But if it's really needed, it needs to be built back into the baseline, and it needs to come in with an updated version through the build process, going forward. It is the AWS API. That's exactly what it is. Yep. So I learned that because I was doing Ansible stuff years ago, probably 2018, and I was doing Ansible stuff up into the cloud, and I was like, I don't have this Boto 3. What the heck is that? And I had to go look it up because I didn't know what Boto 3 is. But now I put that on systems when I need to use Ansible or Python to interact with the cloud, right? But anyway, but if I'm going to be putting that on there, I want to move that back into my build baseline so that those servers for my developers and those kind of things have those things built in, always updated to the most recent version. Because look, who else, just think about this real quick. Who else cares about what the baseline of your security on your systems are? Managers. I mean, they care when there's a problem, and security cares when there's an off of their baseline. But the people that really care are you. The users don't give a shit. The users are only interested in this, their accessibility to the system. You're the one over here pushing and maintaining the security. I hope that's kind of clear on what I'm talking about here. All right. So who enforces standards? And I say, why do we care as administrators? Because we're the ones that see the system in operations. We're the ones who are tasked with uptime of the system. Our primary goal is uptime. 100% of the time as administrators. Uptime is our goal. Now, security is focused on confidentiality, availability, integrity, and availability. That's called the CIA triad. So for us administrators, security is critical because our availability portion of it. Now, it's a real close second place, confidentiality and integrity. But our primary focus as administrators is always the uptime of the system, right? All right. So lab tasks this week, we're going to do some SCC reporting. We're going to harden 3 items from the system. I think I only did 2. And then we're going to rescan the system to see that improve. So let me show you guys. It's going to be bright for a second. Let's talk a little bit about how we actually secure systems. So we have, let me pull this up. It's going to be bright for a second, but got to deal with it. Inside of Killer Coda, I have a few places for you to go. It's part of the lab, so I'm not gonna link it right now, but it's in all the lab documentation. At the end of the Linux labs here, there's an SCC tool to look at the STIG report, Secure Technical Implementation Guidelines, of an Ubuntu server, and then also of Firefox. So if you want to see this happen, the way that we harden systems when we first build them out is it's kind of like a bit of a dance. And I really should have drawn this out. Maybe I'll draw it in a new version of this. But you're gonna test for functionality of your system. Good. Then you're gonna harden the system, and you're gonna verify that you are at the security posture that you want to be. And then you're gonna test that functionality again. And if all the functionality that was originally there is not there, you're going to have to back off certain security requirements, and then you are going to have to get security exceptions for them for whatever baseline you're picking. I'll show you how to do that here in a second, but let me show you what the initial scan looks like on a system. So here's an initial scan. This is a lab that we built a while back. If you want to do this lab with me right now, I guess you can. I'll link it to you guys that want to do it. So here on the YouTube and here on the Twitch side, here's this lab. And we updated it yesterday, so it should be pretty well updated. But it says your team has to integrate with a U.S. government system. Okay. Whatever tooling you're doing, whatever company you work for, there's a security requirement that you need to STIG, which is the technical implementation guide, your servers to a certain score, and you have to decide to use the SCC tool to scan that. So that's a tool that comes from the DoD, right? So we're going to go download. We made a directory for it, and we CD'd over into it, and we're going to go download that tool, right? We've downloaded it. We can look at it and see that it's been downloaded. It's about 87 megs, so it's not too big. We're going to unzip that tool. Still not too bad. Then we're going to CD in there, and we're going to install the SCC 5.10.1 from Ubuntu, and it's going to go get installed in opt-SCC. Okay, good. So we installed it. We're going to CD over to that configuration, or to that directory rather, and then we're going to config the command line SCC tool to be able to do the SCAP, the scoring for us. So here, there's a little bit of a change log. Anytime there's a change, they always give you a change log, so you hit enter. And I'm following along with the left over here. We're going to say that we want to hit 0 to return to the main menu. Okay, so to hit 6 to configure options, 1 for scanning options. And in our scanning options right here, we're going to use 1 to run all SCAP content. So you're going to see that run all SCAP content is there. Good, 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 good. And then I'm going to hit 0 to go back. And then I'm going to hit scanning options, which was actually the first thing I was supposed to do. Whoops. I was supposed to configure SCAP content first. That was the first thing I was supposed to do. And I'm supposed to remove 1 and 3. So we're only using this canonical Ubuntu 2004. We don't need the 18 because that's a different version of the OS. And we don't need Firefox right now because we're not running Firefox on this box. We just want to scan this. And we want to scan it regardless, right here, we want to scan it regardless of if the SCAP's, if it thinks it's needed. All right, so that's the two things we did. And then we're going to back out of here, and we're going to say 9 to scan the system. So this is going to scan the entirety of the system for these 166 rules that exist for our Ubuntu system, right? While that's going, this is going to generate a report for us, right? And as that generates a report, this is what a STIG viewer looks like. This is a free tool that you can download as well. This is our STIG viewer here. And I think I can actually go pull, I wonder if I have this here, if I can import the STIG for, I think I have Ubuntu. Let me go see if I have Ubuntu on here. Yeah, here's my Ubuntu 2004. Maybe I don't have it in my environment here. I got my RHEL 8 and 9 for other things. Here. All right. Yeah, here's my 2004, and there's my 166 down here. So when this scan is done, we're going to come over here and we're going to look. Now there's a few other things that we could do in here that I'm not going to worry about too much, but we could we can slowly fix this system by hand, or we can run an Ansible playbook or a what's it called, a bash. There's bash and Ansible that can be generated to fix this. So let's go ahead and say that we're good. Okay, we've got that. Let's install Apache on this, because I'm going to turn this into a little web page. It's a little HTML file. And we're going to then install Apache. And we're going to look at it on the system to see how secure this Ubuntu box is out of the box. Ubuntu server out of the box, I guess. So let's give it a second. Pull this up here. And we CD'd into... Now, you might say, well, Scott, when you did that, what were you doing? What I was doing was changing directory into the only directory that exists. If you run the scanner multiple times, you're going to have to go find your directories. But I think by this point, if you're doing all my Linux labs, by this point, I think you are familiar with how to move around. And we're going to copy this one right here that says all. And we're going to copy it over into our var www.html index.html, which is the default for what we call the document root of the Apache web server, right? So now, if I did that and I click this, here is my score. Okay. It's a 13.76. That's my score of my Ubuntu server out of the box. Now, we want to get over 90 typically. So this system is not considered very secure. What is it? It's very accessible. It's not very secure. So let's go down here and let's look. There's 3 layers to our STIG scores. There are Cat 1s, Cat 2s, and Cat 3s. Cat 1s must be addressed. So let's go look at the very first Cat 1. This says the Ubuntu operating system must map the authenticated identity to a user or group for PKI-based authentication. That's a fail. That is V238201. I can't remember all that. But I can come over here and I can build a checklist from this marked STIG. And now I can use this checklist to keep track of what's going on with that. Now, there's an easier way to do what I just did here. We don't want to manually do 166 of these. By the way, when I do Red Hat, it's 460. What's Red Hat? Red Hat's hold on. Red Hat's 462. So we don't want to be doing Red Hat by hand. Typically, we'll pull the checklist out, and you do have the checklist generated from this. But that's neither here nor there. Let's say 238201. So I can put these in order. 238201 is right here. And this is going to tell me over here how to fix this problem. So here's the check test. This is how we checked it. We grepped use mappers from this file. So let's go look. If I put that in here, whoops. I didn't mean to put a 3 on the end of that. There is no such file or directory. Okay. So now it says if use mappers is not found or this list does not contain PWENT, this is a finding. So how do we fix it? We set use mappers in that file. So we need to make that file for this to pass. So here's our finding details. And here's our comments. These are 2 things that we have to fill out when we're turning this into our ISSO, which is our Information Systems Security Officer. So I would say if I were going to fix this, I would put that fix in there. So I would say something like this. I would go to, we're going to VI this file if I were going to make this. And then I would go put in this file or put in this line. And then, whoops. I can definitely, I don't know what just happened to my can. Okay. All right. We'd have to make the directory. So, okay. So this isn't even kind of there. We'd have to go figure out why that's not even kind of there. If system is missing that directory and this, we would have to modify accordingly for this other example. So there's an example possibly in our system over here. There would be some PKCS examples for us to go put in there, and then we could go make that directory. But the point is, I can fix this, and then I can mark this. You know, I would mark my findings here, right? And then my comments would say, this is a finding. This is not a finding. And what I can do then is I can right-click on it and say status, not a finding. And then I would slowly get better and better scores until when I rescan this again, right? Because as I get more and more of these as not a finding, I would get a higher and higher score here until I got up to a 90 or greater, and then I could connect to my system. Now, before you look at this and go, Scott, that's a lot of very rigid stuff that has to happen, whereas what we were talking about earlier was like individual little things. And I say, yes, to build a standard and to engineer a standard into a set of servers is a very complex thing, and it is time consuming. This is one of the reasons that we build these. We harden a system and make it a golden image, and then what we do is we use automation tools to update it as we need, so that that system baseline that we keep can always just be modified to stay where we need it to going in the future. And then when we're ready to move off of Ubuntu 20.04 to Rocky 9.4 or whatever, we do this process again on a Rocky 9.4 box, and we harden it to what we want, and we keep that as our golden image, and then we do our changes and we build our system to match appropriately, right? But everything we're doing here, whatever activities we find ourselves doing, at the end of the day, we are dealing with this. Perfect security, because this is the question. I always ask you guys this, right? This is always a thing when we talk about security. I say, if we know that those 166 things in Ubuntu should be there and they're good practice and they work, why don't we just put all 166 of them on and have Ubuntu over here as it comes out where it's locked down and everything works? Well, because nobody will be able to use shit. Everything will be so locked down, it'll take so long. Have you guys ever seen one of those things where they give a present and the present takes the person like 45 minutes to open? That's a pretty secure little present. Like, you need a wrench to, like, I've seen some where they have to undo all the bolts, all the nuts and bolts to get the present apart. That's great, but it's unusable. It's an unusable system, right? So we're always dealing with this. All right. So let's look real quick. SEC report in the actual worksheet for this week. So we've always got a worksheet for the week. This is what you're doing this week if you're following along. Our course is up in our Discord. It's completely free. Here it is on Twitch. And here it is on YouTube, right? Completely free, right? Yeah, it's like a Russian doll. One of those little Russian nesting dolls, yeah. So here's our problems for this week. These are the discussion questions are not designed to trick you guys. I hope everybody understands that. Anybody that's been following along, they're like, I'm not doing the discussion questions to trick you. I'm doing the discussion questions to get you guys thinking about systems admin work. So the first one is, your security team comes to you with a discrepancy between the production security baseline and something that is running on one of your servers in production. There are 5 servers in a web cluster, and only one of them is showing this behavior. So one of them has diverged. It has had a configuration drift from the other servers. They want you to account. And you say, why me? I didn't make the change. You're the one, you're the security, you're the Linux engineer on at the desk when they walk up. I don't know if you guys have ever dealt with this, but you're the one sitting there. You're the one that responds on Teams or Slack or whatever you're using as your tool. So I say, just and this is abstract. So this is like, how are you going to validate the difference between the systems? If they show you a difference, but This is one of those trust but verify. I want to see for myself that there's a difference on the systems. What are you going to look at to explain that there's something different? Are you going to go look at change records and look up all those servers? Are you going to, this is what I tell you guys all the time about like the art versus the engineering of a thing. If I can give you an exact equation, if I can give you an exact set of steps to always follow, then it's engineering. If, however, it's something like this where you're like, well, it could be a little bit of this and it could be a little bit of that and spice in a little bit of that, that's art. I can't boil it down to an equation. So there's a certain amount of art to this. You need to think about where you would go check and how you would explain this. And then I say what could be done to prevent a problem like this in the future. What safeguards could be in place so that your team, this may be your safeguard. I want to monitor my shit so that I know about it before somebody else comes and tells me. I'll tell you right now, if you bring a problem to your manager that your team caused before some other team brings it to your manager might be a little mad at you guys, but I can guarantee you it's better to be the one that tells people. Same thing I tell you guys in the security world when you talk about like losing PII, personally identifiable information about a customer. The number one rule in that, man, guys, there's theories on how you express it up and down your chain to your C levels and how your media and whether you apologize or not, or whether you just talk about how you corrected. There's all kinds of other shit. But the number one rule that always prevails in losing people's data is make sure they hear it from you before they hear it from somebody else. Number one rule. Don't let somebody hear it. Like you're sitting there sipping your coffee in the morning and they're like, hey, there was a data breach of 3 million. This actually happened to me when I was in the Army. There was a data breach of like 3 million soldiers had all of their service records stolen from a server down here in Phoenix. I can tell you guys how it happened. The person knew that there was a server underneath somebody's desk. This was in the early 2000s. I think this was like 2001 when this happened. And somebody walked in. They actually like drove a vehicle up. They kicked the door open. They grabbed the server and they walked out and they stole all our records. Well, back when I went in the Army, your social security number was your service record. So, like my social security number has been stolen since the early 2000s. I don't think anybody's social security number isn't known anyways. But that's neither here nor there. The point is, what could have been done to prevent these things? And also, I remember reading about that in the newspaper, going, well, that sucks. I mean, well, I was an infantry guy, so there was nothing to steal from me anyways back then. But the point is, make sure that you're the one telling your customers. All right, here's discussion post 2. Your team has been giving you more and more engineering responsibilities. So this is a good problem to have. Being the person who's on the admin or the NOC team, but they're giving you more and more engineering tasks. And I say you are being asked to build out the next set of servers to integrate the development environment. Your team is going from RHEL 8 to Rocky 9.4. So they're going from paying for RHEL to Rocky. So you're not going to be certain tools. Satellite's not going to be in play anymore. All these kind of things. And I say, how might you start to plan out your migration? What might you just start doing? What are you going to do to check your existing systems to see the baseline and build? Are you going to go read documentation? Are you going to go see, do we use CIS benchmark? Like what are you going to do? What would you go do? And then what kind of validation plan might you use for your new Rocky 9.4 system? So how are you going to validate that they're hardened to what you want? Now, you might say these are a lot. Well, the other day I asked in the Discord, did you guys want this to be harder? And a bunch of people voted for it to be harder. It's also funny, the people that voted aren't the people doing it. But I'm not gonna take that into account. There's a bunch of definitions that I've mentioned today, and I would want you guys to know what those were. So that's all part of the worksheet. Worksheet also tells you to go work on your system hardening lab and then also to work on your project. That's what these things do. And then there's some labs that'll give you more information about digging deeper. And the reflection questions are always the same for each week. What questions do you still have? You could ask me those up in Discord. And then how do you apply this to your current IT role? And if you're not in IT, how can you put something like this into a resume or a profile so that it looks like you know what you're talking about? All right, so that's our Unit 13. Let me pull up the lab. So the lab for this week is pretty straightforward. It deals with, you go onto a system and you just start looking. There's always a little exercise at the beginning. Go look at what's open, look at what's failed, what's going on in the system. And then I say that you're going to harden a box, or you're going to look at a scan report. You're going to remediate some of those items, and then you're going to rescan. So the scan yesterday took 61 minutes. If you use our professional Linux users group labs that you guys have access to, that took 61 minutes. So just know that that's going to take a while. Then I say go ahead and harden SSH, and harden it according to this STIG. I pulled this out of one of the STIGs there. I want you to take and make sure that everything in this directory has the right permissions. They don't, by the way. So how are you going to, what's your system hardened? Is it hardened? How did you check? You did an ls-l. They actually give you the check right here. You could do that stat as well. But you can also ls-l, and it would show you the permissions. And then you're going to fix the permissions by giving them the proper permissions. And I said, how did you check? And then I want you to remove some unneeded software that's super annoying. It's called CalSay. CalSay maybe doesn't belong on your servers. Now, this isn't directly part of a STIG score, but this is part of the good practice of not having software on your stuff that shouldn't work. So here's your CalSay. If you've never seen CalSay, it just says stuff as a cow. And then you can make him, what is this? You can make him paranoid, you can make him dead, and you can make him stoned. Those are there's a bunch of other ones too. But anyways, then I say go ahead and rerun your scan and see, do you see the validation of at least that one? And you would see that one is more secure. So it's pretty straightforward labs this week. But I'm kind of, I don't want to say trailing off on the labs, but I'm making the labs a little easier as we go into the end because you've got this big project that you have to do for the course. If you guys haven't seen the project, it looks like this. Let's see if we can pull this up real quick here. Project's pretty straightforward. If you're doing the course with us, you've had 13 weeks. There's four deliverables. Build a documentation of your project. What are you doing? Build a diagram of what you've built, and that can be physically, logically. If you're not doing something that takes servers, you're doing something that's more code-based, you can just do a logical representation. I'm okay with that. An example of a system working, so an operations and that, and then a 15 to 20 slide presentation that you can show to the group. It's voluntary, but it shows that you actually did the work, right? And then this is the explanation of how all those work. If you haven't seen some of these tools like Overleaf and some of these other things, there's some really good tools out there for you to get some skills in that. And we have little study guides each week where people, or study groups each week where people are meeting down in Discord and talking about these things and walking through the systems and all that kind of stuff. So this week was system hardening. Next week, which is actually this week, is Ansible automation. So I'm getting the last little part of that. I have the presentation done for that. I just have to go build the labs out. That's going to be recorded today as well. We met the last 2 weeks on this one, and then we met yesterday on this one. I just have to finish the actual work for you guys up. So that's the project. And let's go back here, and it says questions. If you have questions, feel free to message me on the Discord, or just find me wherever you find me, and I will try to give you as much guidance as I can. Anybody that wants to finish the course and get the really nice little present, we're giving a really nice little certificate out. I really think only about 5 or 6 people are on track for it right now. You have to finish the course by January 19th. So we're running the course now. The course will end right at the end of December. But then if people want to crash through and get as much of the stuff done as they can, January 19th will be the cutoff date for turning everything in, having a project completed, and all those kind of things. So, all right. So there's that. And I will go ahead and I'm going to end the stream here. I will come back on in a little bit and do Unit 14. And then I might be on later today just kind of hanging out and doing Linux and stuff. So that was loud. Hopefully, I don't know if you guys heard that, but that was loud. I will be back on here in a little bit working on Unit 14. And I will talk to you guys later.